Now let's take a step back and formalize what we're doing when we are learning. Inductive learning, also known as discovery learning, is a process where the learner discovers rules by observing examples. So these rules are represented by some function. This function is unknown to us. We have training examples. Training examples come in pairs. For each example x, we have the corresponding f of x. Now, for example, x is an email and f of x may be spam or ham, or x is a house and f of x is its price. Our goal is, given this training data set, we want to discover the best hypothesis h that approximates the true function f best. In classification problems, f of x is in a finite set of values like spam or ham or a digit 0 through 9, but we can also have regression problems where f of x can be any number. So what we want to do is construct or adjust our hypothesis h to agree with f on the training set. We say that h is consistent if it agrees with f on all the examples. So for our regression problem, we have to find a curve that goes through these examples. Here's a line that goes through 4 examples. And here's another curve that goes through 5 examples, 5 out of the 6 examples. And here's a curve that goes through all 6 examples. And here's another curve that goes through all the 6 examples too. So which one of these curves is a better hypothesis? There is this trade-off of consistency versus simplicity. So the blue and orange curves here are consistent. They agree with f on all the examples. The green and the red curves are not consistent. They agree with f on 4 or 5 out of the 6 examples, but the green and the red curves are simpler curves. There is this general principle called Occam's razor that states that simpler is better. Now, it may be very subjective to define simpler, but in practice, simpler solutions generalize better. They avoid overfitting. And there are several ways to simplify here. One way is to reduce the hypothesis space. One way to do that is to make assumptions, like the independence assumptions that we made in naive Bayes. That's one way to simplify, to reduce our hypothesis space. Another way to reduce the hypothesis space is to have fewer, but maybe better features. And another way to simplify is to regularize, to smooth. We did that by increasing the value of k in k nearest neighbors, and we also did that with Laplace smoothing in naive Bayes.